This is a lesson about using trig in triangles that are not right, also known as the law of cosines. We're going to start off here with a triangle that's not right, triangle ABC. And in this triangle, I'm going to drop the altitude. And it's important because that altitude creates two triangles that are right triangles. But again, I'm starting off with a triangle that's not right. I'm going to label a little bit more in here so that we have some other sides, since it created two right triangles. And we're just going to talk about some different relationships using some trigonometry, using Pythagorean Theorem, of all the different sides, the sides A, B, and C, as well as these pieces H, M, and N that are in this triangle. So, first of all, I see that base, that part, the MN, when you add that together, that is the same as the length of C. So that's just something to note for this. And I'm going to put a point P there for the altitude, where the altitude cuts that side AB into two pieces, so that I can now talk about this triangle CAP. And I highlighted that in red. So we're going to look at that and do some trig in that right triangle. And we notice that the cosine of angle A is going to be M over B. It's the adjacent over the hypotenuse. And if I multiply both sides by B, I can solve for M and get M equals B cosine of A. Similarly, I'm going to use sine, and sine of angle A is equal to the opposite H over the hypotenuse B. And again, if I multiply both sides by B, I can solve for H and get that H equals B sine A. Again, I'm just manipulating things that I can do. But I'm going to look at the fact that I've got that part 1, n equals c minus m, and in part 2 above, we have what m equals. So I'm going to substitute that in. And I end up with n equals c minus b cosine of A. Now let's look at the other triangle, this triangle CBP. And we're going to use the Pythagorean Theorem this time instead of trig. And I note that A is the hypotenuse and H and N are the legs. So I've got A squared equals H squared plus N squared. But in part 2, I've got what H equals. And in part 3, I have what N equals. So I'm going to substitute those in. Now at this point, I'd like you to expand and collect like terms. You might want to pause the video and try to do that problem out. Okay, so let's just recap before we go into that expand and collect like terms. We started off with a triangle ABC that was not a right triangle. And I'm going to look at the same triangle, but let's get rid of the altitude and those little pieces. So also, please really make note of the angles and the sides. That I have angles A, B, and C, and sides A, B, and C, such that angle A and side A are opposite each other. Similarly, angle B and side B are opposite each other, and angle C and side C are opposite each other. That's very important for what we're going to do this next little part here, this finishing up to figure out what's going on with this triangle that is not a right triangle. Well, I asked you to expand and collect these terms, and the first one, the quantity b sine A, quantity squared, well, that's just going to be b squared sine squared A. But the second one was is a binomial, so you're going to have the first term, c squared. You're going to have the last term, b cosine A squared, which is going to get you at the very end of there, b squared cosine A. And you also get twice the product of those two terms, so minus 2bc cosine A. And now I asked you to collect like terms as well. And you said, well, there's nothing alike. But there's two terms that have a b squared. So I'm going to rewrite those where they're next to each other. And I just put the c squared minus 2bc at the end of that. And since they both have a b squared, I'm going to factor out the b squared and write that with parentheses. And so I have a squared equals b squared times the quantity sine squared A plus cosine squared A plus c squared minus 2bc cosine A. And we go, yay, I got sine squared A plus cosine squared A, which is a 1. So it's going to be b squared times 1, which gets us a squared equals b squared plus c squared minus 2bc cosine A. And this is really, really important. This is called the law of cosines. And again, you might not be going, well, I don't really know what this has to do with, but I want you to remember we started with a triangle ABC that is not a right triangle. And we have this equation that is connecting the three sides and one angle. And it's important which angles and which sides. Let's look at how, because this is a very, very applicable, it's useful in real life formula. So let's look at a situation. So there's these two locations. Location A, so we've got the town of Alice, and then we've got location B, the town of Baker. And so we need to get from the town of Alice to the town of Baker, and we need to we're going to construct a very straight road, and it's going to drill through the mountain and everything. We're going to hire some engineers to make tunnels and everything, but it has to be an extremely straight road from Alice to Baker. So these engineers are able to use a special tool that could measure angles and distances, and they find a location so that they can stand in one place and see the town of Alice and see the town of Baker. And this tool allows them to figure the angle from where they're standing, the angle from A to B is 55 degrees. And they also know that there are 18 units, whatever they're, measuring by, some 18 units from where they're standing to the town of Alice, and 20 units from where they're standing to the town of Baker. And with this information, they're going to be able to figure out how far it is from Alice to Baker, so that we would know how far that road is going, in, with tunnels and everything else, is going to be. And what they would use is the formula, this law of cosines. So this is where the usefulness of this can be. A lot of times there are, in real life, especially if you go back in history, where people had to figure out the distance across the ocean, across a lake, through from one location to another where there's trees and objects in the way that they can't figure out how far it is. So they're going to pick a location where they can see the two endpoints, measure the angle, measure the distances to those, and using the law of cosines, find the unknown third side of a non-right triangle. So this is how it is used. So this is a little bit about trig in non-right triangles.